Somewhere, deep underground in super-secret laboratories, scientists are trying to create a black hole. It looks like the latest experiment was a success. The black hole hovers above the desk for a moment, but then, in a split second, it swallows it whole. Uh-oh. After its meal, the black hole grows until it is out of control. Microscopes and test tubes fly into the dark void. Soon everything in the room has been consumed. Each time it eats, it grows bigger and bigger and attracts even larger objects. On the surface, people go about their day as usual. Some joggers stop their run when they see a giant black sphere growing in the distance. Houses are torn from their foundations, and cars fly through the air towards the black abyss. In just a few minutes, the black hole has enveloped our entire planet. Then it grows big enough to consume the Moon and Mars. The black hole is now heavier than anything in our solar system. All of the planets begin to circle it before becoming food for the monster. Finally, even the sun is extinguished in the belly of the beast. Well, that was pretty bleak. Don't worry, this isn't how the scenario would play out in real life. Our scientists may actually be capable of creating a black hole, but it's far safer than this. The effort to make a black hole is led by the scientists working in Geneva on something called the Large Hadron Collider. This machine basically makes particles move at high speeds until they collide. When this happens, they release a lot of energy and create a lot of interesting effects. Scientists think that energy released by these collisions might be enough to create a black hole. Some people were so worried by this that they even tried to ban the construction of the Large Hadron Collider. Luckily, if a black hole did appear, it would be so small that it wouldn't be able to do anything. Black holes actually produce a lot of energy and release it, often as heat like a furnace. That means that they will fade away when they run out of fuel. If one appeared in the experiment, it would instantly burn out and disappear in a billionth of a second. Even if a stable microscopic black hole was created, it would grow so slowly that nothing would happen. Assuming that it survived long enough to absorb the tiny particles around it, a black hole of this size would take about 500 billion years to gain a pound of weight. Black holes could actually be really useful. One with the mass of Mount Everest would emit enough energy to completely power humanity. Even better, black holes are so dense that the one this big would only take up a tiny bit of space. We couldn't create anything as enormous as the naturally occurring black holes, though. Some can weigh hundreds of thousands of times as much as our Sun. Recently, scientists have observed a real black hole feast. The sight of a black hole tearing an enormous star apart is one of the most mesmerizing sights in the universe. Heavier and more destructive than anything else in existence, the black hole is both amazing and terrifying. And black holes aren't actually black at all. They're so massive that even light can't escape their pull, meaning that they're actually invisible. Scientists can only find them with special instruments. Most natural black holes are born as stars reach the end of their lifespan. You can picture healthy stars as giant furnaces that burn hydrogen and give off unbelievable amounts of energy. Every second, stars like our Sun produce more energy than humanity has ever produced, which pushes outwards and makes it want to expand. This is what eventually finds its way to Earth as the heat that birthed life on our planet. The only thing stopping this expansion is gravity, a force that basically just pulls objects toward something heavy. Most people know gravity is something that keeps us planted to the ground and stops us from flying off into space. The force of gravity of a star is so strong on stars that it makes them want to implode in on themselves. So, when a star is healthy, the force of gravity pushes inwards, and the energy it releases tries to inflate it like a balloon. These forces mostly cancel each other out and stop it from doing much at all. When a star burns through its fuel, though, nothing is pushing outwards to stop it from collapsing in on itself. Some really big stars make so much energy that they gradually expand into something called a red giant. When they run out of fuel, they cool, and gravity pushes the enormous object into a tiny space. Scientists use our sun to measure how big things in space are. Our sun weighs 1 solar mass. If a light star, like our sun, implodes, not much happens, which is lucky if you've ever worried about being swallowed up into a black hole. If a red giant around 10 solar masses implodes, though, some incredible things can happen. The collapse of one of these is so intense that it explodes into a supernova, releasing a light as bright as the entire galaxy. Stars that are massive enough to produce supernovas sometimes become black holes. Their weight causes gravity to push down and compact them until they collapse into a black hole in less than a second. The inside of a black hole is mysterious and unexplored, for obvious reasons. One thing we do know is that they're so massive that they can even distort time. 1 second near the black disk can be equal to weeks or even months on Earth, depending on its size. In 2019, scientists watched a black hole devour a star the size of our Sun. Even though it was 860,000 miles wide, the star was completely trapped in the black hole's gravitational field. For a while, they danced around each other, gradually coming closer and closer. Eventually, though, the star was extinguished in the invisible mouth of the black hole. The black hole sometimes releases beams of energy into space. Sizzling plasma flies out at 6,200 miles per second as the black hole finishes destroying the star. About half of the star's mass is consumed, while the rest is ejected into space. Incredibly, these insatiable titans even consume other black holes when they get big enough. The collision of 2 black holes was recently witnessed by scientists, when one, weighing in at 85 solar masses, met another that was 66 solar masses. When black holes interact, the bigger one always swallows the smaller, adding even more mass to itself. The resulting black hole here reached 142 solar masses big. It's hard to believe, but this is still very small for a black hole. It will continue to consume everything around it and might even reach the size of a supermassive black hole at some point. These are unbelievably big and destructive. Our entire galaxy, the Milky Way, rotates around the gravitational field of one of these supermassive black holes. This monster weighs around 4 million solar masses, or more than 1 trillion times our planet. And that isn't even the biggest they get. It's also theorized that black holes can be made without a dramatic explosion. Big gas clouds that weigh hundreds of thousands of solar masses could condense under the force of their gravity to make a star. This object would already be so heavy that it would continue to compact until it became a black hole, skipping the supernova stage. Supermassive black holes are so far away and hard to observe that scientists doesn't have a full understanding of them yet. We don't know much about what happens inside a black hole, leading to a lot of speculation. For decades, people have theorized about how we could use black holes. Knowing that black holes distort time means that someone could use it to travel to the future with the right technology. If it was possible to build a ship strong enough to withstand the powerful gravitational fields, it would be simple. All they would need to do is decide how far they want to go and fly around the outside of the black hole. In the few minutes or hours they spent near the time warp, years could have passed back on Earth. They could be thousands of years old without having aged at all physically. Wow, that's officially a mind-blower.
Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our Sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the Sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone. The weird thing about Fomalhaut b isn't its name, but the fact that it doesn't exist. It was first photographed back in 2008 and was a sensation. Scientists believe it to be a massive exoplanet, but it turned out to have low mass, and it's falling to pieces of dust at the moment. It acts like a massive dust cloud. Gliese 1214b is quite extraordinary with its steamy environment. Wait, but steam is the result of water evaporation, isn't it? In fact, this hot planet is full of water-like substances. It's definitely hotter than our planet, with its 250 to 540 degrees Fahrenheit. It can also be an ocean planet. Still, very little is known about it since it was first discovered only back in 2009. If you ever wondered what it's like to walk on ice and hot coals at the same time, meet Gliese 436b. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. But Gliese seems a nice place with quite mild climate compared to an oven like Corot 7b. Its stated day temperature is over 4,000 degrees Fahrenheit. Combined with the rocky surface, it presents a kind of underworld landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Corot 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. Corot Exo 3b is neither as hot as the previous one, nor as cold as many other planets. It's a gas giant similar in size to Jupiter, yet 20 times denser. It makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. TRES 2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here, it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. It may mistakenly seem that Saturn does have an Earthen-friendly environment. Some layers of this giant gas sphere actually have quite nice temperature conditions. If you dive into Saturn, you'll get to a layer with liquid molecules with 32 degrees Fahrenheit, which seems like Earth. Anyway, it's only one minor layer, and the rest of the planet is freezing cold. So you'll never be able to land on Saturn and be the same human being like you are on Earth. But you can become a sort of snowball there, or an ice crystal. As for Jupiter, you might have already guessed that there's no solid land. This planet is made of hydrogen and helium, so it's another gas sphere you can't walk on. It's a bit different from Saturn though. You wouldn't dive in Jupiter, you'd rather float on it. This planet is like a giant cloud, and if you ever landed on it, it would be like walking through a super thick fog. The temperatures fluctuate a lot here. It's freezing on the surface. Unlike Saturn, the deeper you dive, the more scorching this gas sphere gets. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot where anything that could burn will. It's also responsible for a very short orbit of the planet around its star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. WASP 76b is another weirdly dangerous planet where it rains. No, not wasps. It's so hot out there, over 4,300 degrees Fahrenheit, that it vaporizes iron. So, it rains iron. It's another gas giant, just like Jupiter. Its extreme proximity to the sun divides the planet in two. One half has a never-ending day, while the other has eternal night. Meet WASP 12b, one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planet consisting mostly of gas, result in the star slowly devouring its protege. WASP 12b has already taken the form of an egg, stretched towards its merciless sun and unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. No list of the weirdest planets could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury, despite being somewhat farther from the Sun. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through those clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. One more freezing cold planet is the one I dare not pronounce. Although the host star is not too far away, it's a small and rather cool red dwarf whose light and heat barely even reach the planet. The temperatures out there fall as low as -370 degrees Fahrenheit, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice. Still, if it has a rocky core, it might generate some heat, so there is a chance that deep below the frozen surface, we could build a nice thermal spa hotel for space travelers. The next planet that sounds like a tongue twister is the only exoplanet in the orbit of its star, and at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst thing is, that winds reach the speed of 5,400 miles per hour, or almost Mach 7. For comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Here's another name we'll just leave on the screen, thank you. This magnetic rogue planet, let's call it SIMP, has probably the best auroras in the universe, putting our northern lights to shame. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees Fahrenheit, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when these cool down, they fall on the surface in the infernal rain of molten iron. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather, the first, because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star with one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. The system, whose name I wouldn't even try to pronounce, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular one. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions, while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely.